We've been working on SPL2 for the past couple of years. SPL2 is live within Splunk's Edge and Ingest processor, and now we're excited to release this powerful query language to our own search and reporting app baked inside of Splunk Enterprise and Splunk Cloud. Let's take a look at the single search editor. Today I used our standard Buttercup Games dataset for our online games store, and I'm creating a report to summarize successful purchases by category ID. So let me get to the single search editor. For customers already familiar with SPL, SPL2 is backwards compatible and maintains a similar syntax, making the transition smooth and straightforward. For new customers, SPL2 introduces SQL-like syntax, which is widely known and easier to adopt. As SPL2 supports SQL-like syntax, I can write the same search command in SQL. As part of introducing SPL2, we're introducing a new knowledge object called a module. A module is very similar to a notebook experience. However, in Splunk, it does many things to make your job quicker and easier. It serves as a powerful environment for analysts, administrators, and developers to build, organize, and reuse complex search logic and data transformations. For security and IT analysts, it centralizes incident investigations and root cause analysis, allowing multi-statement searches with branches, commentary, notes, and collaboration to all happen inside of Splunk, instead of across disparate tools like 30 search tabs, Confluence, and Slack. For power users, it is a file where you can declare reusable custom functions and data schema libraries for your users to reuse and for your data admins to leverage in data management pipelines. For admins, it lets you create views with role-based access control, or RBAC, effectively creating virtual datasets on top of physical datasets within granular RBAC. For developers, modules provide a structured way to build and package reusable toolkits, functions, and types directly within Splunk applications, making it easier to ship complex, maintainable, and discoverable logic to app users. By allowing users to define and connect multiple steps like base searches, filters, lookups, and aggregations, and even embed notes, it streamlines complex workflows, ensures consistency across different analysis, and facilitates collaboration and the sharing of a curated log. Now let's take a look at the modular editor. I'm a security analyst with Buttercup Games, and I've just been informed by our NOC area lead that we're seeing some anomalous shopping behavior from a specific IP address. This immediately raises a red flag, and we need to investigate if this is malicious activity or something else. First, to begin my investigation, I need to fetch raw events where our e-commerce shopping data is sent. I know this lives in our main index, so I'll start by defining a base search. Now looking at the events, I can see the client IP field. If I were to hover over the client IP field, I'd notice that this specific IP address does indeed show suspiciously high volume of activity compared to others. This confirms the initial alert. So my next step is to filter down these events and focus only on this suspicious IP address. Now I will add the where clause to the base definition. Okay, now we have the events from our target IP. We need to figure out if there's a concentration of behavior around any particular products in our online store. Let me see what we have for the product's name. To make sense of this, I need to normalize the product names using a lookup file we have called prices.csv. This will enrich our events with human-readable product names. Now I will add the lookup command. With the product names normalized, let's see if there's any anomalous concentration within product purchases. Is this IP buying an unusual amount of one specific product, or is this a diverse range? I'll use the stats command and group by product name to summarize this. Now I'll add the stats command. Looking at the distribution by product name, it appears quite normal. There isn't an unusual spike in any single product, which is a good sign. However, if it's not product focused, then can it be something else? Let's take a look at the browser activity from this IP address and examine those values. Now let's add the stats and mv expand command. So, this is quite interesting. As you can see, this one IP address is showing dozens of different user agents, indicating a wide variety of browsers. This is a critical piece of information for us. What this tells us is that this IP address in question is likely an intermediate host for a bunch of different individual shoppers that are proxying their traffic through this one IP address, rather than one abnormally high volume, potentially malicious shopper. This client IP field in our logs is capturing only the last IP address of the chain not the original source IP. This explains the high volume we initially observed through this single IP address. Now, I will add my notes and conclusion directly within the module. This allows me to document my thought process, the steps I took, and the final resolution, all in one place. Now, I can save this module and share it with my teammates. This centralized investigation file can be easily linked to my case management system to close out my analyst queue. It provides a complete, auditable record of the investigation.